You should be fine.
All right, sounds good. You are live and ready to go.
Okay, great, thanks. Okay, everyone, we will go ahead and get started. I know it's a bit later on in the day, so first off, thanks for being here and if you're joining us at home. Also, thank you for tuning in. The talk today is a little bit about what I specialize in. It's cloud security, and you see the label here. This is kind of a crash course. We'll look at a lot of different tools and methodologies, and please, I don't expect you to know all of these things, but if you have any questions, feel free to stop me at any time. I'd be more than happy to explain. So a little bit about the agenda and kind of what we're going to cover. This first half will be kind of the PowerPoint. We'll mix in a little demo, and then kind of in the later part, we'll look at a few of these things. We'll look at some really common, I guess, high-level things, right? These are universal across all cloud providers. But before we kind of dive a little bit deeper, I guess a little bit about myself. So I currently work as a cloud security engineer for Booz Allen Hamilton. I am a recent graduate about 2 years ago. I studied software engineering for my undergrad, then went on to get my master's, and maybe most importantly, former EHC member. You know, this is kind of bittersweet for me, you know, kind of being on the other side of the table. It's unique, but a little bit about myself. As you can see, there's a couple of certs, a couple of achievements there. So hopefully at least I know somewhat about the topic today. And so before we kind of dive deeper into the security side of things, you know, we'll focus really on that first part, right? What really is the cloud? You know, it's one of those things that gets talked about a lot and kind of thrown around, but we'll kind of really define exactly what it is, right? And then once we kind of understand that, we'll kind of expand into that and look at it a little bit more into the security side of things. So it has a couple of key defining characteristics. And you can see them here. There's really three big ones, and we'll break down each of these individually, right? But kind of the big theme here is that we have options, right? This is something in the past was not really a thing. Mainly it was dominated by a couple of big providers, but now kind of with this shift to remote work, and obviously the pandemic and everything else going on, you know, the cloud seems like a lot better option for a lot of companies, and that's whether you're a super small, right, or a really giant organization. So let's talk about some of these essential characteristics. First and foremost, it's the broad network access. So no longer are we kind of tied to these buildings or locations, right, to access our infrastructure. We can do it anywhere. And kind of piggybacking off of that, it's on-demand self-service, right? We don't need to wait maybe for a certain hardware part to get shipped. We don't have to necessarily phone up anybody and say, hey, I need this certain, you know, server spun up. And that's a really big deal, you know, especially with things like the chip shortage. I'm sure if you're all aware, if any of you are into gaming, you know, the shortage of chips and GPUs and things like that. You know, one of the really nice things about kind of moving to the cloud is that you're really never going to run out of those resources. And because kind of this cloud is really big, especially with these big three providers you see here, we get to take advantage of something called resource pooling. Because they're so large and a lot of customers, you know, kind of flock to these services, we really get to reap the benefits of exactly the infrastructure that they've built out that they've allowed us to use. And maybe one of the most important ones, and something that we'll take a look at a little bit more in depth later on, is that rapid elasticity, right? We can spin up and spin down instances or really anything quickly. And this is a really big deal, not only for small companies, but also really large, right? Imagine if you're a Netflix, for example, right? Especially with the pandemic and things going on, or maybe it's the holiday season, you can probably predict that more customers will be tuning into your service, right? So how do we, you know, kind of make sure that we have enough, you know, instances and, you know, infrastructure to support all of that need, right? With the cloud, we can quickly spin things up, spin them down. And kind of a shift from the traditional model, you'll hear it sometimes, CapEx versus OpEx. We have these measured services, right? So really, we're only paying for what we use, right? There's no more kind of signing contracts in advance, you know, getting a big piece of hardware or a lot of storage in, right? And maybe only using 50% of it. So we can definitely take advantage of some of these services and really lower costs. As you see, these are kind of the three big cloud providers. There's also a lot smaller ones. Linode is very popular, Heroku, different things like that. But these are kind of the big three, and we'll touch on each of them a little bit, and then kind of in the second half, we'll dive a little bit deeper into AWS. And the reason for AWS is, one, that's kind of what I specialize in, so that helps. But also, it's kind of by far and away the biggest, especially at the enterprise level. You know, it was kind of around first, so it kind of has a head start on everybody else, and it's definitely the most mature model. So let's talk about service models. Again, this big theme being that we have options. And as you can see here, you can kind of read it top down, kind of the lower we go, the more responsibility we have. And so we're using these services kind of every day, whether we realize it or not. All the way at the top from this software as a service, right? Things like Google Chrome, Gmail, right? These things that we don't have to worry about, right? We're not worried about the security or maybe the networking or the storage, right? We just get to use them. And then kind of going down to that second layer, that's platform as a service. And this is kind of a special tool, right? Heroku's a really popular one if you're kind of more into the development side of things. Elastic Beanstalk from AWS is also another popular service. And this kind of takes away that responsibility a little bit more to us, but still we get to abstract a lot of those underlying infrastructure, networking, computing things away. And then finally, infrastructure as service, something you're probably most familiar with. These are the VMs, right? If you've ever spun up maybe a virtual box or at home, maybe you have some type of VMware server, this is it exactly. So again, when we kind of start going lower and lower, more responsibility shifts to us. And later on, we'll kind of look at exactly where does that responsibility line start and where does it end. So lastly, deployment models. And as you can see, there's a couple of different options in kind of how we define or what we exactly want from a cloud. This top option is public cloud. Again, these are the things we've kind of the most familiar with or heard about. This is the Amazon Web Services. This is the Microsoft Azure. This is the Google Cloud. Right? And then kind of we get a little bit more specialized when we go lower into kind of the private community cloud. Right? One of the options that a lot of these cloud providers have is to kind of give yourself an isolated sandbox, if you will. That kind of says, hey, this is really only mine. Nobody else can touch it. So no longer are we sharing kind of server rack space with everybody else. We kind of get our own little slice of the pie. And then at the very end, it's hybrid. So this is kind of a mix and match between the two. And as you can see, there's different kind of layers of responsibility in terms of who owns it and who's responsible for what. So those are kind of those big characteristics, right? Things that kind of they all share. But this is a really nice thing, right? We have all of these options, but there's a big benefits with that. First and foremost, there's no need to really maintain data centers anymore. If you look at what makes a business unique, right? What is it that you really care about? You don't really care about the underlying hardware or the infrastructure they use, right? If you're using, Gmail, for example, you don't really care that it's run on some Cisco server, out in California somewhere, right? What do you really care about? That just the service works. So really what makes companies unique, and one of the things they're trying to kind of move away from, is maintaining the hardware. It's expensive, it's time consuming, it takes a lot of really skilled people to kind of go down and work at all those different layers. So like one of the big shifts we're seeing is kind of abstracting that away and getting rid of that difficult task. And again, something we touched up on earlier, we're trading those upfront expenses for variable expenses, right? It's a pay-as-you-go service. No longer do we have to buy a big server, use the server, maybe 10, 15%, and then we're not really using that, other 80 or 90%. And we get the benefit, of kind of scale, right? These cloud providers are huge. And because of that, they've built out a lot of infrastructure and a lot of really unique services that isn't really possible anywhere else. Or if it was, it'd be really expensive to do. And then kind of one of those things that we talked about earlier was that idea of going global, kind of in minutes. There is no more, kind of having to wait around for anybody. We can just spin up or spin things down whenever we want to. But with any pros, there's also some cons. Often what you see in enterprises especially is that they're using one cloud provider. And that can be a bit tricky, right? For example, let's say I use AWS exclusively. Well, maybe they raise the price, $10 for a certain thing I'm using per hour. Well, all of a sudden you have some questions to answer. So vendor lock-in is a real concern. Also, especially if you're kind of moving and migrating to the cloud, how do we integrate that with our existing architecture? Maybe we want that kind of hybrid setup where we still want to use our stuff kind of on-prem, but we also want to take advantage of the cloud. Those migrations and those integrations can be tricky. And also we talk about this data governance, sovereignty. We're kind of moving back and forth over the internet, this maybe secret classified data, right? How do we make sure that we know maybe it's encrypted, maybe it's not encrypted, right? We can't really go out and touch those data centers, whether it's AWS, Azure, or Google, right? So we need to really be careful. And finally, skills gap. This is probably the biggest one, and I see it all the time. What I get to do, especially as a consultant, I get to work with a lot of different teams and a lot of different organizations. A lot of people kind of want to move to the cloud. It's the hot, flashy thing, right? There's a lot of benefits. You know, if you don't kind of have a really good plan, or especially the people in place to pull that off, you know, things get tricky quickly. So let's look at the basics. We've kind of talked about, you know, what the cloud is, right? We understand that there's a lot of benefits. There's different kind of models that we get to pick, which is nice. We've looked at some of the pros, and, you know, also some of the cons. So I think there's three big things that we really need to focus on. And these three are really, in my opinion, what makes the cloud a viable solution. And they're kind of these three big ideas, and we'll touch on each of them. But the first is shared responsibility, right? We kind of touched on it earlier. We said that not necessarily, you know, what makes a business unique is kind of their data, right? Their product, not exactly the underlying hardware. So we can kind of abstract some of that away, take some of the heavy lifting off of us, and kind of pass some of that responsibility on to the cloud provider. The second one is something that security professionals have been clamoring for years, and this is integrated identity. So kind of like if you have a lot of Apple products, right, there's a certain ecosystem. Everything plays nice with each other. It's kind of the same way here. Picking a cloud vendor and using kind of all of their services, right, we kind of get that nice little ecosystem, and we can integrate everything together with identities. And the last one we'll touch a bit more later on, and this is by far and away the most important. It's API coverage. And if you're not exactly familiar with what APIs are, they're just kind of a language that services kind of communicate between, so we can share data between. But again, we'll touch on these things a little later. So I guess question for all of you and for those at home, you know, we're talking about the security, right? We've seen the cloud, right? Let's kind of dive a bit deeper into that security section. So what really is the goal of cybersecurity? You know, what are we trying to accomplish? Any thoughts? Please. Oftentimes you'll hear this kind of, you know, all the, you know, the integrity, the privacy, the, you know, that kind of CIA triad model, right? You know, that's nice, but I think we can break it down, and it's really a lot simpler than that. You know, it's make sure that systems work as intended, you know, and only as intended, right? That's kind of the goal of what we're doing here. You know, by following, you know, this kind of template, this kind of model, understanding, you know, where we're starting, what we ultimately want to get to, you know, this is it. So we kind of talk about security maybe between this blue team, red team, right? Blue team being the good guys, red team being the bad guys. So let's kind of understand, you know, what are we up against, right? If we're kind of on that blue team and we're just defending our, you know, infrastructure in the cloud, you know, who are the people we need to look out for? You know, what's the biggest threat? You know, is it nation state actors? You know, these are kind of what you hear about on the news, right? This is China, this is Russia. You know, these are all these other countries. And, you know, with enough money, with enough time, with enough expertise, right, anything can be broken. Nothing is 100% secure. So it's not really these guys. Maybe it's insiders, right? These are people within your organization, maybe that have privilege access, that you trust, you know, with all of your kind of configurations. And, I mean, maybe, but again, this is kind of an HR problem, right? You know, if you don't really have the trust in place or the contracts or everything kind of sorted out beforehand, you know, this isn't really something that we can necessarily control. So, you know, it's not really these guys. So maybe it's cyber criminals, right? These are these kind of smaller organizations. They often work for money. Like I said, over the past couple of years with the ransomware attacks of Revil, was kind of that cybersecurity gang. You know, this would be them, right? They primarily work for money, small groups, and, you know, yeah, but again, we can't really control this. They're definitely a concern, right? But, you know, if anything is vulnerable enough, if anything has enough time, enough money, right, things can be broken. So it's not these guys. And the point I'm really going to hammer home today is it's this right here. It's misconfigurations. What we're about to talk and what we're going to look at is really the security in the cloud is misconfiguration security. And one of the really big themes that we'll look at is how do we put controls and policies in place to kind of mitigate some of these misconfigurations. So it's not just me saying this. This is a really popular company. They're called Fugue, and they kind of specialize in cybersecurity and more so cloud security. Their CEO, Josh Stella, was actually AWS's former security lead. And as you can see on this kind of graphic here, and what they talk about is that these misconfigurations, the things that we really need to worry about, not only happen every day, but they happen a lot, right? 1 to 10, you know, 24% of the time, that's a big deal. And especially kind of as we start going lower, you know, maybe to 100 and, you know, kind of, 200, 500,000. Not a big, you know, not a good thing. The cloud has a lot of benefits, right? It's that rapid elasticity. We can move quickly. We can spin things up whenever we want to. But with that kind of comes some challenges. So I think it's important for us to understand just how quickly these misconfigurations can happen, and look at, again, who are we up against. So quick demo. This is Canary Tokens, and this is a service, kind of like a honeypot, if you will, that we can kind of send out into the world, right? And it will kind of let us know who's trying to talk to us. So if you've ever used GitHub or another, source repository service, this is, they kind of have a public API, right? And we kind of said earlier, APIs are the way that, services kind of share things between each other. And so we can actually test this. Let's say I'm a developer, right? I am, kind of going through, and I get lazy, right? I have these access tokens, I have these credentials to log into my account, and I just kind of want things to work, right? I don't necessarily want to, go through all the hardship of all the security and all the controls and things like that. So we'll make a file, we'll call it test.py, and we'll just call it, configurations maybe, and we'll paste in these credentials. And as you can see, these are AWS credentials. And there's kind of two main ways to access AWS. This is one of them programmatically. The other one that we'll see is through the console. But this is a public repository. GitHub has a public API that anybody can query. And we'll kind of put this out there. So now anybody, anywhere can kind of go look at this file and query to see exactly what's on there. And this is a big concern, right? One of the areas that I kind of specialize in, you can sometimes hear at DevSecOps, is preventing things like this. Kind of putting these checks in place. That way things like this never even get committed or never even get pushed up to these source code repositories. So we'll let this run for a minute. If anybody's got a timer, I guarantee you it's going to be less than 2 minutes. But we'll see just how quickly these things can be exploited. So we'll come back to this in just a second. And again, we'll kind of get these emails that go in and tell us exactly who's trying to access what. So while we wait for that, we will go back and we'll look at, kind of in the security field, we don't really need to reinvent the wheel. Right? We can learn from others. There's kind of already these checks and balances in place, and already these frameworks that have been laid out, long before us. Right? So there's no point, kind of trying to do it all of ourselves. We can leverage things that other people have done and learn from others. And the first way we're going to do that is with that shared responsibility model. This is kind of one of those big three things that we talked about. And as you can see here, it kind of lays out the differences and the responsibility lines between each things. So as you can see on the left, this is the traditional model, right? This is kind of before the cloud really got popular. This is the on-premise. And as you can see, we're responsible for everything. And that's a really big deal, right? We're going to have to hire, or at least have trained individuals that understand really each layer of the stack. And getting all these teams to coordinate together and getting kind of one big security plan can be challenging. So moving to the right, this is something that we kind of see a lot. This is the VMs. This is kind of at the lowest layer if we choose to use these cloud services. And as you can see, just like that, already half of the responsibility is not on us anymore. Right? And that's a big deal. No more networking, no more storage, no more servers. We don't necessarily have to worry about those underlying things anymore. So moving on to platform as a service, it's even nicer. Again, we only have to worry about kind of those top two layers, and then a software as a service, things like Gmail, things like Outlook. We don't have to worry about those things at all. So if we go back and look, maybe we refresh, see if we have any takers. Not yet. No problem. Maybe in the junk. Not yet. Okay, no problem. Cool. So we're going to learn from others. We looked at the shared responsibility model. That's kind of a framework set for us. And now we're going to look at adoption frameworks. Most businesses are kind of migrating to the cloud. If you're lucky enough, maybe you kind of start from scratch and that's where your kind of home base is. But for a lot of people, it's that migration. So what we're really going to do here is kind of, map this idea of kind of who's responsible for what. That's these business processes, and identify who's a stakeholder, right? Who's going to work where, who's going to manage these things. And most importantly, we're going to make a plan. Right, this cloud is kind of this big, vast thing with lots of services and lots of kind of fun things we get to play with. But again, one misconfiguration, as we've seen that happens often, can be detrimental. And so how we're going to do that is we're going to look at something called the CIS Foundations. And if you're not familiar with what CIS stands for, that's the Center for Internet Security. And they have a really nice kind of layout, kind of a guidance, if you will, maybe a checklist, kind of something that says that, hey, we can start here or maybe this is kind of the end goal, something we can move to, right? And this is a really good baseline to start maybe kind of looking at eventually down the road if we wanted to migrate, or something that already has, again, kind of this framework, these controls laid out for us. That way we're not reinventing the wheel. So we're going to need to answer a couple of questions, especially from the security side of thing. We're going to have to be able to look at these things and determine, first and foremost, what happened, right? We need to know if something bad happens, what exactly happened. And this kind of leads us into one of those big ideas of logging and monitoring. Kind of those two big questions are what happened and who or made of what happened. A big point here is that we want logging and monitoring in place first, not after, right? We don't want to spin up all this infrastructure and then kind of play catch up to figure out where everything's going. And every cloud provider has their own kind of unique service for this. For AWS, it's CloudTrail. For Azure, it's Monitor. And GCP or Google Cloud also has its own unique service. But again, this needs to be in place before. This needs to be this is kind of the cornerstone, really, for me at least, when it comes to security. And this can get complicated quick, especially if you have maybe 500 servers in the cloud, or maybe you're moving petabytes of data. Right? Where are we going to store that? How are we going to track that? Right? How do we know what data to track? Right? So this needs to be definitely first and foremost. So let's say the worst happens, right? We kind of have this logging and monitoring, right? We're tracking things now, but we really need some kind of context around that. So what we're really going to ask is, who's there? And this is that integrated identity we talked about earlier. And those kind of big questions are, well, who are you? Right? And what are you allowed to do? And then magically, I can't believe it, all three cloud providers got in line and called it the same thing. That's IAM, that's identity and access management. So this is going to allow us to kind of see, these are kind of those usernames, passwords, right? If you're an admin, you're allowed to do this. If you're a regular user, you're allowed to do this. In the past, this was a bit difficult. Primarily because on-prem there's a lot of different systems, a lot of different kind of plugins that kind of had to be glued together. Microsoft Active Directory is probably the most common, if you heard of that. But again, that has its unique challenges. While it works well for Windows, it doesn't necessarily extend to the rest of the infrastructure. So one of those big components with the cloud is, again, that unified ecosystem, and this is already built in. And the best part is it's free. This comes with every service. So this is, for me, one of those really big deals. So we talked about login monitoring, right? We said we needed to track things. And now once we track things, we need some context around it, right? This is that identity, right? Who's there? So, we've kind of looked at, these cloud service providers, kind of tools that are built in for us. But now we need to get a little bit more focused, right? We can leverage these services, right? But there's always going to be some custom configurations that we need to talk about and that we need to look at. So the first one, and probably the most important for me, is networking. So and this really comes down to, in the cloud, right, we have kind of these public and private networks, and one of the things we'll look at earlier are these ideas of VPCs, right, these kind of individual, kind of virtual private networks that are built out for us. But really the recommendations here is to maximize what the cloud gives you. A lot of these networking services are absolutely free. And again, if we kind of think about what we looked at that stack, a lot of this gets abstracted away from us, right? No longer do we have to worry about, what fiber cable am I going to use? What's the underlying networking routing protocol, right? All of this is kind of abstracted away. So there's kind of three big areas of focus. The first one is networking, and the second one we'll look at is compute. Most often you might have seen it, these are these EC2 instances, right? These kind of virtual machines in the cloud. These could be Linux, Windows, or basically any other flavor. But what we really need to keep aware of is that responsibility, right? That goes back to that shared responsibility model. And it's, kind of, some of these areas that kind of cross over between the cloud and traditional things are definitely that hardening the OS and, kind of fixing issues early on. And kind of we'll look at these things called pipelines a little bit later on that will allow us to kind of put these things in context and kind of really give us a strong fence or a strong kind of boundary to move things through. So we have networking, we have compute. The last one that we have to have pretty much to make anything work, that's data and storage, right? And this really and truly, for a lot of people, is the one that's the scariest. Again, we're kind of trusting an outside party that we really don't have a ton of access to with, what really makes businesses unique, right? What businesses really care about. So a couple of things that we need to do, absolutely first and foremost, it's encryption. That's kind of really the only controls that we have when we're kind of moving to that cloud service model. And also we kind of need to look at these life cycle strategies. And what I mean by that is things can get expensive quickly in the cloud. One of the things there that is nice about it are these options. and we can kind of, if we're saying, for example, that we don't really, need a ton of storage right now, we can spin it down. Or maybe I'm not going to access it very frequently. Well, there's options for us to say, hey, look, I want a little bit lower cost strategy because I'm not going to access it as much. Maybe give me a discount. And finally, identity and access manager, kind of what we talked on earlier, that kind of integrated identity. We need to be able to put up really strong boundaries that say, hey, who can access this data, right? And then who can. So I hope that makes a little bit more sense. Now we'll kind of move in and look at a little bit of a demo. And to kind of give you a lay of the land, this is the architecture. We're kind of here on this client side, and we're kind of going to go out to AWS, inside this thing called a VPC, which quite literally is kind of a virtual sandbox that isolates us from everybody else. And we're going to spin up 2 services. The first one is EC2. This is kind of that compute that we saw earlier. It's kind of that VM in the cloud. And the next one we're going to spin up is S3. This is Amazon's data and storage servers. So we'll take a look at that right now. So, and as we can see, Canary tokens, this is one of the things that we looked at earlier while we're here. Looks like we have a hit. Somebody tried to access it, and we can look at some more information about it. Kind of see who are they at, where are they from, and it looks like a few people, one up in Canada and one maybe out in Oregon. So again, kind of going back to that misconfigurations, they can be deadly, right? We really need to be careful on exactly, who has access to what, and kind of where we store this information, because again, one bad misconfiguration and things can happen in an instant. That's kind of the speed and the complexity that we have to deal with, versus kind of on-prem in the cloud. Things can get a lot more challenging. So let's look at, again, spinning up this EC2 and this S3. And one of the ways we can do that is with the console. This is AWS's kind of main dashboard, and kind of we're going to go in and launch one of those EC2 instances. So we can do that now. It's pretty intuitive. It kind of has a fairly straightforward UI. Sometimes it's not the best and it can be a bit buggy. But again, so here we're going to kind of pick what is it we want. And this nicely is actually in the free tier, so that's cool. So we're going to pick the Amazon AMI. This is a Linux. And now it's going to ask us, what size do we want? Here we're going to keep it relatively small. Again, it's 1 CPU, 1 gig of memory. But as you can see, we have options, right? We can get up to as big as you want. But again, kind of with these, more advanced options also come bigger cost. So for now, we'll stick to the free tier since, this is kind of just a demo. And it's going to ask us a couple of things. It's going to say, what kind of storage do you want? It's going to say, what do you want to leave open? How are you going to connect to this instance? Right? And kind of this is a security group, and we're saying here, hey, open port 22, and this 0.0.0 just means everybody. So anybody on the, World Wide Web, if they have, the time, or if they know kind of where this instance is, they can access it. So we'll launch it. It's asking us for a key pair. I already have one, so we don't have to worry about it. And here we go. This is it. And again, what have we done here? We didn't have to call anybody. We didn't have to, wait necessarily on like a server admin or something. We can just do it ourselves, instantly, globally, from anywhere. So our instance is now launching. That looks good. We'll go back, and we can actually connect to this thing. SSH, and then so let's move into that directory. Let's see, we need to go desktop, presentation, resources. Cool. And then, yeah, nice. Okay, cool. Then we can SSH. Yeah, and there we go. Right. So now we're connected. And again, I can make this a little bigger, zoom in. Yeah, there we go, right? Now this is our virtual server in the cloud, and we can put anything on this, right? Maybe you want to put some, a little small storage on here, or maybe you want to have some type of web server, right? Maybe it's a load balancer or kind of a proxy service like Nginx. It can really be anything. So again, this is nice. We've spun it up. Everything's great, right? We can access it. Yeah, that's great. So then we'll look at kind of that second big part, which is that S3 bucket. So this is the compute, and now we'll kind of move on to that storage part. So back to the console. Again, we can look at S3 here. And again, this is that storage service. Again, these are probably the 2 most common AWS services. And again, it gives us a nice little UI to say, hey, you want to create a bucket. I can name this bucket whatever I want. Choose where do I want to launch it in. For now, we're launching in the North Virginia data center. It's going to ask us a couple of rules. Block public access. Do we want encryption, yes or no? And after all, we can create a bucket. So it'll spin it up for us, and then we can go and upload things in here. Like I said, it could be files. It could really be anything that's an object. As long as it's not kind of block level storage, anything can go here. And again, it gives us a nice UI to kind of click through and do things. So this is nice, you know, and this is good, right? We haven't necessarily done anything wrong per se, but there's a couple of things, I guess, that it's a problem with this kind of approach. You know, can anybody think of any problems, especially as it relates to kind of scale, you know, and as it relates maybe to the security side of things? Please, like I said, there is no wrong answers. Or how could we do this better? Maybe that's please.
The approach you're talking about is like using the web UI.
That's exactly it. Yeah, that's exactly it.
That'd be a lot of clicks for a lot of.
Man, you hit the nail on the head. That's exactly it. Yeah, this is a lot of clicks. You know, in these big enterprises, the one I'm working in right now, I think they have over 1,000 EC2 instances and about 70 or so S3 buckets. We'd be here all day clicking through, right? So there has to be a better way, right? Clicking through and doing this, you know, is nice, but, you know, not only when it comes to turn to scale, right, but also security, right? How do I really control someone that kind of is, you know, has access to this web UI and, you know, kind of just go in and create things whenever they want? So there has to be a better way, and it turns out there is. And if we go back to the slideshow, nice. So again, we talked about a couple of the problems of the approach. It's not scalable. It's kind of difficult to track who's doing what over time. You know, changes become difficult, right? You know, who is kind of responsible for what and who's spinning up these things. And again, you know, we go back to misconfigurations, which is our biggest concern. You know, it's just one missed button click, right? It's just missing turning on encryption, or it's missing, you know, this certain, you know, firewall rule, right? So there's got to be a better way, and there is. You know, kind of one of the big themes throughout the cloud is really all of these problems that we have. You know, they're software engineering problems, right? You know, we have a way to automate things, and these kind of express in programming languages through loops, right? These kind of for loops, while loops, and even kind of at a higher level, you know, the ability to kind of reuse things and, you know, not start from scratch, things like libraries or modules. And so one of the tools we'll look at here that kind of allows us to do some of those things is Terraform. This is kind of a cloud agnostic, works with all of the big providers tool that allows us to kind of write this stuff in code, right? And this is kind of something we're familiar with. And, you know, it's going to give us a lot of big advantages, especially later on, but the biggest one is not having to click through the UI 1,000 times. So let's take a look at it. And this is exactly what it looks like. And this is Terraform. So we can kind of take a look at and kind of break down a few of these things. But again, I don't expect you to know all of this. But at the very top, we're basically saying, hey, Terraform, what cloud provider do we want? We want AWS. You know, what is it that we want to spin up? All right, we want to spin up an AWS instance. That's that EC2 instance that we just did through the web UI. You know, what else do we want? We want this bucket. And, you know, finally, if I want to upload things to it, you know, I absolutely can do that. I can just say, hey, I'd like to upload an object. And what would I like to upload? I'd like to upload a picture, right? So no more going through the UI. We can do this all programmatically. And, you know, this kind of language, which is HashiCorp's, you know, kind of Terraform language here, is really easy to understand, right? There's not a ton of complex, you know, loops or scope or, you know, kind of, you know, non-naive syntax here. So let's do exactly that. And we can spin this up, and if everything goes well, we should get the main results. So again, just like how we compile programs, the way Terraform does it is by this Terraform init. So what's really going on under the hood here is that this programming language is kind of reaching out to AWS, and it's saying, hey, AWS, you have this public API, right? You have this way for me to express exactly what I want through this language. All right, let's go do that. So then we can take a look at exactly what is it that we're going to do. All right, do this plan command here. And if we give it a second, configuration, yeah, cool, great. Okay, so it looks good. We don't have necessarily any big changes. Nothing is wrong with the code per se, and now we can apply. And I might be in the wrong, yeah, this is why. Apologies, I'm in the wrong folder. We should be in first demo. So let's run that back. Again, just like we compile programs, we're going to init, we're going to say, hey, you know, this is what we want to do, HashiCorp. Go out to AWS, initialize the backend, kind of take care of some of that heavy lifting for us. And then we can look at exactly what it is we're going to spin up. You know, this is that plan command. I mean, we'll kind of get an output here to say, hey, look, you know, we're going to add 3 things, right? What are we going to add? we're going to add, we're going to add this, if I can find it. We're going to add this AWS instance, right? We're going to add some storage. And these are kind of all of the things that we haven't necessarily defined yet, but for our purposes aren't necessarily that important. So again, this kind of programming language takes a lot of the heavy lifting off of us. And finally, we can apply. So hey, I have all these changes. Here's what I'm going to do. And let's push it up to AWS. Go ahead and build that infrastructure out for me. And that's exactly what we're going to do. So again, what have we done here? We've taken away that web UI. We've taken away all those clicks. We've kind of taken away, that responsibility to where it's just, we're kind of one misclick away from having a misconfiguration. And we get a lot of advantages that we'll see a little bit later on with using things like infrastructure as code. And kind of one of the big themes we'll see toward the end is kind of everything as code, right? How can we, force, or how can we, kind of make people use, code instead of clicking through the UI. So again, a lot of kind of cloud problems are really software engineering problems. So if we give this a couple of seconds here, again, because these APIs are kind of talking to each other, Terraform can be a bit slow at times. That's just kind of the nature of the beast. But as you can see here, it's kind of spinning up these things, and that applies complete. So we can verify these changes. We can actually go back and go into our console, and we should see another EC2 instance here. Yeah, and we do, right? Now we have 3. Previously we had 1, and we can actually take a look at it. Yeah, and here they are, right? This Terraform demo EC2. And then we can also confirm it with this kind of S3, which we said is that data service that Amazon allows us to do. And again, we kind of uploaded something into this, and I gave it public access, so anybody anywhere can access it. And there it is. And we see we have a picture in here, and we can actually kind of, go and look at that through the World Wide Web. And again, it's the man, the myth, the legend. Everybody loves him this year. It's Bruce. He said, I think we have a game tonight. So he said, no, I'll try to keep it brief. But yeah, so cool. So we've done all this stuff, right? We've gotten away from the web UI. We said, hey, everything is code. It gives us a lot of advantages, but still, we can do better, right? How are we going to do better? One of the kind of challenges now with this infrastructure as code, right, is this, how do we track things, right? How do we keep everybody from just, kind of going through and spinning up their own things, willy-nilly, right? So we need some kind of standardized way, right, to make sure that the code we're writing, right, is safe. And so how we're going to do that is kind of move it through a pipeline. And by a pipeline, you can kind of think about it just like an assembly line for cars, right? It's going to kind of go through and stop along the way, kind of run some tests, run some checks. And if that passes, we're going to kind of move along. And how we're going to do that with something called Jenkins. This is another really popular cloud tool. This is kind of, you'll hear the CI/CD, continuous integration, continuous delivery. The idea being that by using this pipeline, we can actually release code changes multiple times a day, or infrastructure changes in this case. And this is huge. In the past, it was kind of, write a bunch of code, you meet every 2 weeks, right? And then we make a big push to prod at the end, and you say a prayer, nothing breaks, right? But that model, A, doesn't scale, and for B, a lot of companies, it's not very sustainable, right? Now you're kind of hinging your hopes on that once every 2 weeks on a Friday, that the code compiles, we push the prod, and all of your users get the new features bug-free. A better way of kind of doing this is, let's say, hey, let's push things out kind of continuously. Like maybe we're making 3, 4, 5 changes a day, right? But because we have this pipeline in place, because we kind of have this assembly line that's going to check things throughout its life cycle, we can kind of afford to do that. So one of the big things about Jenkins and why it's really used a lot are these plugins. And the plugins for just about anything and everything you can think of. Again, this is an open source tool, and it really kind of aids in software teams. So again, what I specialize in is this kind of stuff, right? This kind of DevSecOps. It's building these pipelines. It's kind of writing these unit tests, these integration tests to help developers, really kind of speed up their workflow. So, why do we need it? We touched on a little bit of those things. Really, it's kind of to build and test changes, in that standardized environment. If you ever used a tool like Docker, it's kind of this container service that really solves the problem of, hey, your code works on my machine, but it doesn't work on another machine. By kind of pushing all of these things to Jenkins, we can actually, kind of get away from some of those problems. And again, manual testing is difficult, right? What I think is a good test and what you think is a good test are 2 completely different things. So let's standardize that, kind of putting in that central place, like that assembly line, like the pipeline, and do it there. So we'll take a look at it. And this kind of, there we go, excuse me. And this is kind of the architecture. This is kind of what we're going to do at a very high level. Again, this is kind of that pipeline. This is kind of that kind of assembly, and we can kind of read this left to right. So we'll have a developer. We'll write some code. We'll push it to kind of that source code repository. Again, that can be GitHub, GitLab, or just about any other service, right? And it's going to trigger this thing called a webhook. A webhook is basically just something that continuously pulls a check for changes. And then once you see that you've kind of pushed that change, it'll go in and grab that code. It'll kind of build and test it. And if everything goes well, we kind of push those changes to prod, right? And if it doesn't, we'll kind of publish the results back and see kind of what went wrong. And this is huge too, right? Because now developers kind of have this instant feedback. It's not waiting 2 weeks and everything breaks, right? It's not necessarily some manual code review that might take a lot of time. We can kind of automate all of these things away, right, and get feedback instantly. So a little bit of kind of what this looks like, or the way it is now, is just like this. Right now we kind of have this EC2 instance, and on that instance, or on that VM, Jenkins is running. And kind of what the pipeline looks, and we'll kind of look at this in a second. This is kind of going to go through these stages, right, and reading it left to right. We're going to initially commit to GitHub, and then we're going to kind of run a couple of services under the hood. Docker is probably the biggest one. Again, that's a container service that's going to standardize everything for us. And inside Docker, it's going to run a couple of tools. Terraform, which is one we looked at. And this is kind of our testing framework. This is Open Policy Agent. It can do a lot of things. It does Terraform really well, though. You can kind of compare this if you've kind of used Java for the couple of the undergrad classes here. This is kind of JUnit, right? This is this testing framework. And finally, if everything goes well, all of our tests pass, right? We're going to deploy it. So let's take a look at it. And this is Jenkins. This is what it looks like. And again, you can kind of tell from the top, this is running in our EC2 server. And currently I have a pipeline, and the pipeline is called demo. And of course I'm logged out, so if you give me a second, I'll log back in. Great, cool. So as you can see here, trial and error, I was kind of building some tests before this, but this is actually that visual representation of the pipeline. Right, and again, we're going to have these different stages. Right, the first one's going to be in that checkout. SCM stands for Source Code Manager, and again, that's going to check out that code from GitHub. So we can actually run this, but before we do that, let's take a look at exactly what is in this repository. What is it we're going to be, I guess, comparing against or kind of pulling from. And we can see it here, presentation demo. Great. So I have this file. This is a test.tf. Again, this is a Terraform file. We looked at a little bit of this, but it has some misconfigurations, some things that we might not want. And again, we have to be really careful, even not only in that web UI, but also in code. Right? And we have two big problems here. The first one being that ACL. It has public read-write. Not necessarily the best thing for your kind of data and storage. This is basically saying, hey, look, I'm going to create a bucket. Right, and on this bucket or on this kind of storage object, anybody from anywhere can access it. Right? Probably not the best. And piggybacking off of that, we have another one called versioning. Versioning allows us to where if we accidentally maybe delete a file or move it to a bad place, this will kind of keep up a backup for us, kind of a version of the previous object or file. So we're going to look at kind of, this is the bad example, and we're going to kind of make sure that Jenkins can catch error like this. So again, it's kind of moving kind of from left to right. It's that initial commit stage. It's kind of that automated way of doing things. So I need to make a change. I need to commit code. That way Jenkins can kind of pull that code, and we can kind of do an example here. So if I can get my folder structure, perfect. Great. Okay. Cool. So in here I should have that test.tf file. Yeah, and there it is. Great. So we're just going to make one change. Maybe we'll just add a comment somewhere, right? That way we can kind of trigger that kind of, commit to the repository. And again, this is our Jenkins file. So this is kind of what's going on under the hood. And for now, we'll just say test commit, right? That's a change. We can verify that's a change. By looking in here, we can say, hey, what did we modify? We modified this Jenkins file. So let's add that, kind of prepare it for it to get commit and eventually pushed up. So what did we change? We changed that Jenkins file. My auto indent, nice. Great. So we changed that Jenkins file. We can commit it, and we'll have a message. And we'll just say, hey, this is a test. And finally, we can push it back up. So, excuse me, I forgot to pull. I must have made some changes beforehand. let's see, and of course, always a live demo. These things happen. Um, let's see, can we not push? One failed. Get status. Okay. Get tests. Get tests. Get push. Now get pull. Get pull. Auto conflict. Is it get merged? Oh, like I said, this is I guess the devil's in the details. But we can avoid this, right? We'll just make a change actually on the repo itself instead of kind of going through this. And we can do that same thing. So we'll edit the file. We'll go to the bottom. We'll call this test. We'll commit it directly to the main branch. Commit. Great. Now that we've done that, and we should see here at the bottom, yeah, right, number 17 is now kicked off. And again, this is that automatic way. It's using that webhook to kind of do things, and we can take a little bit of a deeper look at this to see kind of what's going on underneath the hood. And this is it. So this is actually one of these plugins that we talked about. This is Blue Ocean. It kind of gives us a nice graphical interface to kind of view these things happening in real time. But as you can see, it's kind of going through that assembly line that we talked about. In that first step, it's kind of initializing, it's kind of formatting everything for us to get it into an output to where we can test it. So again, it's going to kind of build that Docker image, the kind of self-contained container. It's going to have all of our testing frameworks in it. It's kind of going to move left to right. And again, these are some of the commands that we've already run, right? We've run this Terraform init. We kind of ran, as we'll see earlier, that Terraform plan. But again, I don't necessarily, as a developer, have to worry about that local testing anymore, right? I can automate it away, right? And this will do it for me. So initialization looks good. We can take a look at the planning stage, right? This is Terraform plan. This is something that we just saw earlier. But again, now Jenkins is kind of taking care of all of this for us. And then we go to the testing stage. Not good. Something failed, right? Something didn't work. We touched on it earlier. This is that open policy agent. This is kind of the J unit, right? The testing framework. And we get an error message. So the pipeline failed. And the error message, kind of says, that these permissions that we have, or the versioning that we talked about earlier, isn't good, right? So we need to kind of modify those things and change things. And again, this automatically stopped it, right? Those misconfigurations are such a huge deal, and they can happen so quickly, and it's so easy to do, right? Things like these are absolutely necessary to have in place. So let's modify it. We kind of have two things wrong, and then we can, look at that and modify them. So the problem was that in our test.tf, we said that this ACL, was too permissive, and then we also said that we need versioning enabled. So let's do exactly that. Let's make these changes. That way Jenkins can run again, test these changes, and to make sure everything's okay. So for our ACL, we'll change it to private, right? And this kind of lets us only look at these things, and then we'll change versioning to true, right? So track changes over time of these different objects, and make sure that if something bad does happen, or maybe an accidental deletion, we have those things stored. So again, we're changing it to private, making sure that everything enabled is true. We'll commit those changes. Again, Jenkins will automatically kick off again for us. And then we can actually look at that. If I go back to demo, and there it is, right, number 18, right? And it even gave us the commit message, the one that we just made. So we can take a look at it again, and now hopefully if everything went well, this should kind of pass. So again, let's think about where we started, right? We started with that web UI. We started off by saying, that this was an okay way of doing things, but there's some problems, especially when it comes to scale and also security, right? One missed button press could be catastrophic. And then we kind of moved over into this thing called infrastructure as code, right? This was the Terraform that we saw. We said that there's a better way to do it, right? We can quickly, write loops to kind of automate things and do, spin up thousands of instances. We can kind of build out our infrastructure in really a human-readable, easy to understand language. So, and then we kind of said, well, that's great, right? But how do we make sure that, there's a standardized way of testing these things? How do I make sure that, my tests match your tests, and that there's this kind of standardized environment to run everything with? And then we moved on to Jenkins, right? This is that CI/CD pipeline, kind of that assembly line that not only is going to run all of our code for us and automate all of those tests, right? But it's kind of this kind of gatekeeper, these kind of strong barriers in place to make sure that, any changes that we do make or any changes that we want to provision are secure. And this is huge, right? So now instead of, the traditional model of deploying software every 2 weeks, right, merging it all together and, kind of saying a prayer that it works, this is a lot better system. Now we can kind of continuously, as long as all of these test cases pass and we write good tests, we can kind of, deploy software, multiple times a day. And this is huge. If you are a Netflix, for example, and maybe a change gets pushed out and it breaks your service, right? You can't really wait 2 weeks for the service to get fixed, right? You kind of need that, automated way of kind of delivering those features and those fixes quickly. So it looks like our test passed. That's good. And we can take a look at them here to confirm if it'll ever load. If not, I might have to refresh. But again, as you can see, we're initializing, spin on that Docker container, kind of make it a uniform, way of running things, and then move on to kind of formatting, right? How do we kind of take this Terraform output and making it into something testable, right? In that testing stage, that's applying those unit tests, those integration tests, kind of throughout the pipeline. So it seems like Jenkins is holding up, but that's okay. Well, I guess we get the main point here. But again, the idea is that this testing stage is run, right? It's going to automatically deploy, and we should see those changes reflected in our AWS account. And we can actually probably test that. If we go back to our AWS console, right, we can see those things spun up. Nice. And again, what did we say? We wanted to spin up this S3 bucket, right? So we'll navigate to the S3 service just to confirm that our test did pass. We kind of automatically deployed that S3 bucket, and that whatever, kind of those permissions that we applied, are there. Yeah, and we've exactly done that, right? So, great. Okay, cool. So I hope that gives you a little bit of a better idea of exactly, kind of what it is I do and what it is I specialize in. Again, it's kind of that later half, right? This is kind of that DevSecOps. You'll hear it a lot. It's kind of writing these tests, kind of writing out these pipelines, again, to really help developers, and kind of teams in the cloud, kind of either A, move to it, or B, kind of, migrate, into a more secure state. So a couple of best practices to leave you off with. And, if you look at these, you might be like, yeah, okay, sure, like definitely, like this is kind of obvious, right? Use encryption, things like least privilege, right? This is kind of cybersecurity 101, if you will. But you would be absolutely shocked. These kind of basics, these foundations that kind of underlie, no matter what the system is, are so important. And a lot of companies really kind of, miss the ball or miss the mark when it comes to those basics. And again, those last two things, it's everything is code, right? We don't really need to be going through the web UI. Changes are hard to track. It's not scalable. So really everything needs to be as code. Not only infrastructure as code like we saw with Terraform, but also this kind of policy-based automation, kind of what I do, writing those strong tests and writing out those pipelines. So here's a couple of resources. I would strongly recommend if this is a topic you're interested in or this is something you're going to want to explore more into. These are really good. These first two here, these Rhino Labs and the Summit Route, are kind of these CTFs that really specialize in kind of cloud security misconfigurations, and these are great resources. Especially that second one, the Summit Route, kind of those last two, that flaws.cloud. I know there's an event going on this weekend, is that right? And I think it's hosted up in AWS. So if you're looking for some practice, I think that's a great way to start. And finally, Fugue and this Cloud Security Alliance, we touched on Fugue earlier, but the Cloud Security Alliance is kind of like a governing body for the cloud. It kind of lays out these frameworks and these big ideas that we need to think about when it comes to security. So again, those are the links. Feel free to have a read. All of these kind of resources, especially the papers, are 10, 15 pages. It's not too bad. But if you're looking for more of a structured way of learning, right, kind of a start and an end, and maybe you want kind of a result out of it, I would recommend maybe looking at certifications. This is AWS's kind of certification path, but again, every cloud provider kind of has their own unique, kind of options. But this is kind of a structured way of learning, right? This is kind of a defined set of material, right? You learn X things, you kind of get Z output. And at the end, you kind of take a test, you pass the test, and you get the certification. That's kind of one of the stamps in your resume. You say, hey, look, I have at least this level of knowledge. And again, it kind of separates you, I guess, maybe from, kind of other stacks in the resume. But I would definitely recommend, again, if you're looking for that more structured learning, that is a viable option. And again, one last resource, me. If you'd like to stay in touch, these are kind of the links. You can find me in Discord. This is the LinkedIn, GitHub. And again, all of these slides and kind of these presentations are available, so you can go and kind of try these things out, if you will. But please, this is kind of bittersweet for me, right? I used to be on the other side, kind of sitting and watching the presentations, but actually getting the opportunity to come back, and kind of teach and present was something I always wanted to do. So this is a unique opportunity for me. And I was lucky enough with my time at Auburn, and kind of outside as well, to have really good mentors, right? Really good teachers, professors, people that I really relied a lot upon. And they kind of helped me, I guess, get to where I'm at today. So if I can be, half of what my mentors were, maybe to each of you or anybody else, that's something I'd really like to do. So please, like I said, drop me a message in Discord or whatever else. I'd be more than happy to help. So with that, that's about all I got. I know that's a lot. Again, we went over a lot of different tools and a lot of different configurations. But again, this is kind of that wrap up where if you have any questions, please feel free. Anything at all. Okay, no problem. Well, I'm sorry. Go for it.
Where are you working now? Are you working online?
Yeah, so everything is remote. Kind of with this cloud stuff. It's all accessed over the internet, right? There is no kind of physical building we go to anymore. And yeah, that's kind of one of the reasons that this kind of cloud thing has really taken over and probably will in the next few years, is that, kind of remote work with the pandemic and things like that. So yeah, I work remote, but again, it's not that much different from in person, right? As long as you kind of have those good communication, patterns and, everything is kind of agile now, Scrum, right? Everything's in kind of these 2-week sprints. We're using things like Jira, Confluence, right, to kind of track progress over time. Yeah, that makes sense. Again, any other questions?
How do you feel about the logging and monitoring that comes built in with
Yeah, good question. Good question. I think it's definitely a great place to start. If you're a smaller company, right, and maybe you can't necessarily afford those big upfront costs, like, kind of buying these servers yourselves and maintaining them, right? One of the reasons the cloud's such a popular option is to kind of move away from that. That's kind of the out-of-the-box solution, right? That's kind of the default, if you will. But especially for corporations that need something maybe a little more custom, right? Something that kind of has some more features built in. That's kind of when we look at, different SIEM tools, right? That's kind of the security information event management, kind of this one thing to ingest everything, all these logs. A really popular one is Splunk. I see that one a lot. Logarithm is a really popular option. But again, it really depends on the use case. But I think it's fantastic out of the box. It kind of logs and tracks every different API call or every different infrastructure, kind of spun up or who accessed what. So I think it's a great place to start, but it really just depends on your use case.
Does it watch like your ingress, egress?
Yeah, that's exactly it. Sure. So
does it do any type of IDS, or is it?
Yeah.
So it is pretty. Like they do a substantial.
Yes.
Like it's not,
Yeah. The out-of-the-box solution is really good. Like I said, by default, but again, if you want some kind of more customizations, so really underneath the hood of these logging and monitoring tools, they kind of break it down into different, I guess, kind of logging categories. One is something called VPC flow logs. So that's kind of all the traffic inside of your little kind of network, I guess you will, inside these different cloud providers. That'll give you that traditional, this is kind of the ingress, egress port, right? These are the, public and private IP addresses and all that traffic that kind of moves into it. But there's also a separate section, right? This is kind of the global kind of API calls that it can track as well. So again, you can write custom rules and custom alerts that are baked in to IAM that'll trigger to say, hey, look, if somebody's trying to spin up an instance and they have that public read-write, right, deny. Or if there's an API call that says, hey, look, they're trying to access the root account and they maybe shouldn't, right, automatic deny. Right, because now everything's an API and it's this unified kind of ecosystem or language, right? We can write rules, right? There's no more kind of, plugins or different integrations with all these tools, right? It's all, baked in, and that's a huge deal. Does that make sense?
Yep.
Cool. Okay. Anything else?
So, like
Please.
you said earlier, we're seeing a big increase in the use of the cloud.
Sure.
Do you see more companies going to like a full cloud solution, or do you see more of the hybrid model where they're keeping some on-prem?
Yeah, no, great question. I would say it's definitely the hybrid model. One of the things you'll find if you work in this field, or I guess maybe anything software related, or especially in the cloud, often the problem isn't necessarily a technical solution, right? Maybe you already have the people, you've seen that this cloud thing is definitely kind of the future, right? You've said, it's definitely something that we should move toward, right? But it's kind of that battle of, hey, we already have this existing stuff, right? We don't just want to throw it away, right? We paid a lot of money, we signed a lot of contracts, 5-10 years in advance. So that becomes a challenge, kind of integrating, I guess, that on-prem stuff kind of up in the cloud. Like I said, how does that data talk between each other? And, it's a challenge, but I definitely see now more people, I guess, moving to the cloud and leveraging those native services. Kind of on-prem is maybe for their, legacy or maybe, demo or test environments, things like that. Does that make sense?
Yeah.
Cool. Okay. Anything else? Please. Go for it.
So you mentioned like encryption at rest and encrypted
Mhm.
transport when you're using like S3 or cloud storage.
Sure.
As a best practice.
Mhm.
Are you aware of any cloud providers that have implemented in any sort of way, like end-to-end encrypted storage on cloud sides? So like
Yeah.
keys are kept client-side only, stuff is just encrypted as a blob before being
Great question. Yeah.
uploaded.
So one of the things we kind of talked about earlier was that these idea of that we have a lot of options with the cloud. S3 specific, they kind of have these different layers of keys. The service inside of AWS specific is called KMS, Key Management Service, and we have options. We can either, if we're on-prem and we kind of have that infrastructure built out, we can kind of import our keys up into the cloud and we can use it there, right? So we can encrypt on our end, and then by the time it gets to the cloud, it's already encrypted. Or we can send that data, and AWS will manage all those keys and encryption for us. Cool. So that's all I got. Again, thanks for being here. I know it's a little bit later on in the day, but please, if you have any questions, feel free to reach out to me. Thanks. Yeah, absolutely.
And that's all we're doing today. Just so you are dismissed if you are anxious to leave, or I don't know.
I was about to say, I think the game started at 6. I know.